Alright, chapter 4 gets us into quadratic functions and other stuff like that. This is going to be a fun chapter for those of you who like a challenge. It probably won't be for those of you who don't like a challenge, but hopefully all of you are at the point where you're starting to accept the fact that your intelligence is going to get you through the majority of this stuff, that there might be a little bit of a fight. But again, the beauty of being in a fight is knowing that you can come out on top. Not feeling the other way where you know you're going to get knocked out. But I think you'll be able to make it through it as long as you, again, follow me through everything, ask questions over everything you need, and, again, make up whatever you need to make up and stay up to speed. This portion here, the first portion of what I'm going to talk about, the first 4 parts, were taught in Algebra 1, Chapter 9. It has 4 parts that are covered in this first portion. The key x, or what we call the key x, the axis of symmetry, the vertex, and the max or min value. Although there are 4 parts in this first section, it all stems from one process that gives you everything you need. Hopefully you have a graphing calculator with you so we can start to kind of learn some of those buttons. Again, like I said in the bell ringer, you must practice these skills. You can't just assume that, you know, because you do the skill one time that you're just going to remember when you need it. You have to kind of push the buttons a few times in order to get used to it, and then after a while it becomes second nature. And you do want to do that with both types of calculators because both of them have their own strengths. The key x, what we call the quadratic function, again, I'm kind of throwing vocabulary in here loosely. That's one of my weaknesses, but it saves time a little bit. The quadratic function, which is y equals ax squared plus bx plus c, again, you saw that last year in chapter 9. It is a function that's shaped like a parabola, which means it's U-shaped. We've seen it before. This graph has a high or low point that is unique and extremely important. Due to its importance, I call it the key of the parabola. And so the value of x that leads you to the high or low point can be found by using the formula negative b over 2a. Now again, I hope you are listening. I would always use, like, there's certain times, for example, let's just give you a quick math example because you're semi-professionals now in my eyes. If you're on a road that is straight, can you drive 100 miles per hour on it? Probably not the safest thing, but you probably could. All you have to do is keep the car on the road. If you are on a road that's going like this, is it safe to drive 100 miles per hour? Probably not, because there's a lot of curves where you need to slow down and you need to kind of get your steering under control, and then maybe you can speed up a little bit, but then by the time you speed up, you got to slow back down. Now, I am in no way encouraging you to drive 100 miles per hour, but I need you to understand that as a mathematician who is now almost semi-pro, there are certain times where you can start to use your common sense. The formula for the key x is negative b over 2a. And you can do it the way I'm going to do it in the book or in these notes. Actually, I'm going to do it in the notes the way I should do it, which is the mathematical way. But what a lot of people do is they like to plug in the numbers like negative 3 over 2 parentheses, whatever, which is fine. But my common sense tells me that the opposite of negative 3 is a 3. And so why am I going to run the risk of missing that part by not using common sense? So when you find the key x of each of these, here's what I'm going to do. First off, again, your experience from before taught me that a is attached to x squared, that b is attached to x, and that c is the constant. That is also your y-intercept, if you remember that, because when you ignore your x's, that's the number that's left over, if you remember that bell ringer we did. So, again, I will write the formula, but when I write the formula, I'm going to use common sense. What is the opposite of b? Well, b is negative 24, which means the opposite of b would be a positive 24. What is 2 times a? Well, 2 times a, if a is 2, would be 4. 24 over 4 is 6. That is my method of doing that. Now, again, the standard way is to put in negative parentheses, negative 24 over 2 parentheses 2, which is positive 24 over 4 over 6. And if you need to do that, there is nothing wrong with that. But what I am telling you is that if you always have to follow the formula, you're going to waste a little bit more time if you don't start using a little bit of your common sense and finding spots on the road where you can speed up a little bit and say, you know what, I'm not going to type all that or write all that stuff in there because it's not so hard to do. But you'll get practice on that today. I hope you get enough practice because I'm pretty sure I set it up for you. Either way, you're looking for your key x on the next one, so it's x equals negative b over 2a. And so again, b is negative 48, which means the opposite of b would be 48. A is negative 3. 2 times a would be negative 6. 48 divided by negative 6 is negative 8. So yes, we have the calculator, but we really don't need it in a lot of these situations until we get to other things. But I suggest that you try to practice it that way because, again, as an Algebra 2 student now, especially a 6th-grade Algebra 2 student, you want to start using more common sense, more analysis, more understanding than anything else. Here on C, negative b over 2a. I did this on purpose to just kind of make sure you're aware that b and a are both 1, because whenever there's no number there, that means that, that there's an invisible 1. So that would be a positive 1, which means that negative b would be negative 1 over 2 times 1, which is 2, which means my key x is the fraction negative 1/2. Alright? So that is how you find the key x. It's very quick, very easy. I'm going to somewhat speed up a little bit here because I see that I'm already at 5 minutes and I need to keep your time at a decent, efficient rate. Axis of symmetry: in the parabolic shape of a quadratic function, it is symmetric to the key x. All that is needed is to identify the axis of symmetry is to write the answer as an equation. Let me show you an example real quick on the back side of this. If you have a parabola, and that is the vertex, or your key x, if you fold this over itself, it's going to work. Even if it's over here, if you draw a part through the key x, which leads you to the high point, you notice that it cuts it in half, and it is symmetric about both sides. So the axis of symmetry is a vertical line. The fact that it's a vertical line means all we have to do is write the equation. So looking back at what we did, the original equation, again, the reason I'm doing this is to save time. This first part was that x equals 6. That's what we learned. And so your axis of symmetry is, put a colon, x equals 6. That is how you have to type it. On the computer, you just must simply type x equals whatever your key x is, which is 6. My second key x was negative 8. And so all I have to do is say that my axis of symmetry is x equals negative 8. My third key x was negative 1/2. And so for my axis of symmetry, all I have to do is type x equals negative 1/2. That's all. So again, that's easy enough to do. Axis of symmetry is your key x. Just put it in equation form and you will get it. The reason why people miss it on the quizzes in my other classes, my 135 classes, for example, is because they do not put the x equals. Just remember the easiest way to remember, the axis of symmetry belongs to x is to look at the word axis. I hope you understand that the x is both capitalized and bold printed, which is why you can kind of remember that when you see axis of symmetry, that is just your key x, and that'll help you out in terms of remembering what's going on. The vertex of the parabola is the ordered pair which the parabola changes directions vertically. It is the point that I put on the back side of those papers. The vertex is here and the vertex is here. It is also that point that we typically moved whenever we graph them in our parent functions. So again, the vertex, you understand what it is, but again, the x value of the vertex is the key. So again, without the key, you can't do all this stuff. That's why we talked about it first. All you need is basic calculator programming to find the corresponding y value. So let's look back again at the problems. I'm going back to the fact that we found our key x to be 6, and all we have to do is plug 6 in. So you might want to write 2 parentheses 6 squared minus 24 parentheses 6 plus 1, because that's what you're going to do. And again, this calculator, being in the same family as the other one, works the same. 2 parentheses 6 squared minus 24 parentheses 6 plus 1 equals, we get the answer of negative 71. I hope I did that right. 2 times 6 minus 24 times 6. So that equals negative 71. And so your vertex is 6, comma, negative 71. Because this is the value of x that we found as the key. That value of x led to that y. This is now your vertex. The second key x that I found, again, was negative 8. I don't think we want to go through all that again. You'll get enough practice with that. But again, all you have to do is now type that in or put that in there. So negative 3 parentheses negative 8 squared. I'll write it out, and you should probably write it out for your notes also, just for the sake of knowing where it came from. But again, just plug that negative 8 in and make sure you type it in effectively or appropriately. So negative 3 parentheses negative 8 minus 48 parentheses negative 8 minus 2 is 406, which means your vertex is negative 8, comma, 406. Even in the case of having a fraction, it's not so bad. I wanted to do this because you need to get used to fractions. This fraction, I believe, again, was negative 1/2. And so we want to put parentheses negative 1/2 squared plus negative 1/2 minus 3. And you can do that using the parentheses. Again, parentheses on your calculator are very important. So parentheses negative 1/2. You cannot, there is no ABC button on this calculator, which is why your fractions must go in as just 1 divided by 2. Squared plus parentheses negative 1/2. Again, practice this because you're going to need it at some point. Equals negative 3.25, which we know to be 3 1/4. But again, if you want to put this in officially, I would put negative 0.5 comma negative 3.25. However you want to do that, doesn't really matter, because whenever it comes to the actual problem, you'll know whether you need the halves or the 0.25s, and you'll hardly ever have a fraction that, or a fraction type of question that wants a vertex or anything like that. So again, make sure again you are writing this down, seeing what's going on, because this is a one-day lesson. Each parabola is shaped like a U, talking about the max min value, and if that's the case, then it has a point that represents its peak or its valley. Depending on the direction of the parabola, you must be able to determine whether a vertex leads to a maximum value, which would be a peak, or a minimum value, which would be a valley. Remember that the only element you can that switches the direction of a parabola is the negative x squared term. So remember that again, if you're looking at this, this is a hill. That means that this would be a maximum, because that's as high as you can possibly go. That if it looks like this, this would be a valley, which means that this would be the minimum point that you can go. Again, if you're walking on this, you're going to reach a high point. That would be a peak. If you're walking on this, you're going to reach a low point, which would be your minimum. And that's all you need to understand. Now, that's not all you need to understand, but it's the main part of what you need to understand in order to get here. So looking at this, keep in mind the analysis portion. That is my x squared term. My x squared term is positive, and so we know that the way, if you don't remember from graphing, it means it opens up. But the way I remember is that positive is happy, which means it's going to do this. That means that this has a minimum value. This is not happy, which means it's going to be this, which means it has a maximum value. This is also not happy because it's negative, so it's going to be sad, a sad face, which means it has a maximum value. This is a happy number, which means it's going to smile. Again, your x squared is positive, which means that it has a minimum value. Now, I will even admit that when I was making this sheet, I did this and thought it was a max, but you must look at the, you must, pretty much it's easier if you just draw a quick sketch of what it should look like and then say, is that a peak or a valley, and then name it. But again, that's going to be part of the practice that you have, the skill set that you need to keep up with what's going on. The actual maximum value is found at the vertical location. This means that the variable of y represents your maximum or minimum. All that is needed to indicate your max or min value is to write as an equation. Let me show you the other ones here, because again, this is just to show what's going on. The vertex of the first equation was this. And this represents your y value, which means your max or min value is going to be y equals negative 71. Kind of like the axis of symmetry, but the difference is because it's a vertical location, you must use the y value. Your vertex for part B was this number here, negative 8406, x and y. And since the max value or min value is a y, you're going to now put y equals 406. This was negative 3.25 after we did all of our work, and so therefore your max min value is y equals negative 3.25. Now I don't care whether it's a max or min. We could figure that out by saying that because this is positive, that's a minimum, that because this is negative, that this is a maximum, that because this is positive, that's a minimum. Your main thing is to be able to find that value. And before we move on to the 5-point chart, let's go back to what I said in the beginning, which was that all 4 parts stem from one process. If you did not find your key x, you would not be able to find your key y. You would not be able to find your vertex. You would not be able to find your axis of symmetry. You would not be able to find your max or min value. So that is the most important part of it, just to make sure you know what's going on. All right. So last thing I want to get to before we get ready to go. is where we actually graph the parabola. So this is the second portion of the notes. The first was just the 4 key processes, but this is really, really important also. You're going to create a 5-point chart using the vertex as your center. Surround your x values with the appropriate ascending/descending order to complete the chart. You'll understand what this means when we actually do it. These words are just here to guide you when you go back to study. Then use your calculator to find each corresponding y value, and we will focus on the non-fractional examples, in other words, a and b, because we've already done some work on both a and b to do this question. Alright, so as we look at this, the reason I like using the same thing is that we can get to it. So x, y, chart, 1, 2, 3, 4, 5 lines. The center is here, 1, 2, 3, 4, 5. So the third would be your center. And again, we know that the vertex of the first graph is 6, -71. So again, after you've done the the key x in the process to find the vertex, and you don't need to find the vertex to start, but your key x has definitely got to be there. As it says, once you have your x, you will now surround it with its ascending or descending numbers. The number next to 6 is 5, and then 4. The number after 6 is 7, and then 8. And you will now, and again, I hope you get your calculator out now and do it, because I'm going to show you a trick that will make this easier to deal with. You will now type this in. So we'll do 2 parentheses 4 squared minus 24 parentheses, 4 plus 1, 2x squared minus 24x plus 1, and you get -63. Now watch carefully, because here's what we do. We hit second enter on this calculator, and it brings it all back. Now what it does for me is now all I have to do is arrow back using that side arrow and turn my 4s into 5s, which makes life a lot easier. -69 here. Now I'll go back, I'll hit second enter, go back and turn them into 7s. This is the reason why we want to work with these things, because there are things you can do to make your life easy. And then go back, second enter, turn those 7s into 8s just to make sure we did everything right. Notice that we get -63. Now if you look carefully, you should notice a pattern. First matches last, second matches fourth. If you cannot draw this silly looking rainbow, it means you did not really find the vertex appropriately, because this is the only point that occurs once. Every other number, because it's symmetric, is going to occur twice. The vertex only occurs once. Alright? Looking again at what's going on, we have another xy. Again, we've already done work on this, but let's look at what's going on in terms of the actual numbers. This was, I believe, -8, 406, and we already did that work, which is why there's no need to do that work again. The numbers that surround -8 are -7 and -6, -9 and -10. Again, you simply surround it with the numbers that are in order. You then go to your equation and you simply type it in. So -3 parentheses -6 squared is most important. You type the first one in appropriately. Otherwise, all your numbers are wrong. So slow down here. I shouldn't even be talking while I'm typing it in, but let's live dangerously. -3x squared, 48 times -6, and we get 178. Cross your fingers and see what happens. Now we hit second enter. We turn all of our -6s into -7s, and we get 1. I don't think that's going to happen. -3x squared. We'll see. We'll figure it out. So that would be 187. I might have made a mistake that you probably already knew about anyway. Second enter. Turn on my -7s into -8s. Let's just see what's going on with this. And we get 190. So that's 187 here, 190 here. Second enter. Turn all my -8s into -9s. And now you see why the 5-point chart actually helps us out, because the fact that this matches tells me that I messed up a long time ago and you just did not stop me. And I blame you for this mistake. Now here is an issue, because if I try to put a 10 in here, you notice that my 0 would type over the part there. So if you ever want to be a programming expert, if you look above the delete key, you see insert. I do not want to type over this part with this cursor, so I hit second insert and then type my 0 and then arrow over. Replace the 9, insert a 0, hit enter, and you get your 178. So other than that, like I said, you can draw your silly rainbow here off of those numbers. Sorry for the mistake, but again, I could not stop it in real time once I had recorded it. I don't know what the heck I did wrong, but life goes on. Other than that, go on to your Math Excel, get some practice, and good luck.